Alright, so here we are at Bear Creek. We just walked up a bit. We were talking about how Bear Creek is like the only proximate pristine landscape in the Pikes Peak region. Proximate to the city, that is. And so we just walked up to get away from the nature center. And what we're looking at now is the forest composition. So luckily there's some leaves on the trees so we can start to see some of the species. So do you see species that you recognize? We've got like an interesting ecotone right here between foothills and the riparian life zone. So some of the species, like this one right here that's kind of reddish, this is the mountain maple, okay? And this is a riparian species, and you know, has a broad range, would go all the way up into the montane, maybe up into the subalpine depending on the aspect. And then right below it, these leaflets, these very green leaflets, are like wild rose, and that's also native. These lance leaves right here, this is lance leaf cottonwood, which is a middle elevation populous species in Colorado. And then these yellow leaves up here in the tree are also leaflets, but it has a broader structure. Obviously it's a tree, not a shrub. So the first leaflet was a rose, and this is the green ash, which is a non-native species. But it's fairly naturalized and not one that we really go after. I was kind of surprised in Sonderman that they were going after the green ash, you know, alongside the Siberian elm. The Siberian elm is just way more pernicious. So now we're looking at this one right here. Notice it has like an upside down triangle look, and it has this dark bark. And these are serrated single leaves, and that is the alder, which is another like foothills to montane riparian species. And then when we look all the way up, we are seeing primarily lance leaf cottonwoods. And right here I'm not seeing Populus deltoides of plains cottonwood, but they are here. And then as we come down and look into the foreground here, this is a rather tall form of a oak. Yeah, and the Gamble's oak is just this ecosystem right here, which is the foothills. You know, in this landscape we have the oak, and we have some Ponderosa, juniper, pinyon pine all mixing together. And notice here, remember when we were at Sonderman, or at Concrete Coyote, we looked at a place where they were managing the Siberian elm by pruning, and so it took tree form. But where they were not managing it, it looked a bit more like this, which is just a lot of stems, you know, young saplings. And over time, certain ones will take over. But it's important to note that the mammalian population in these landscapes are browsers, right? So deer eat wood, and moose eat wood. So they are not grazers like, pardon me, I just misspoke. Deer eat grass, they're grazers, and the moose eat wood. They are browsers. And so when we think about moose and where they are, all in the riparian life zone throughout various elevations in Colorado, they're always proximate to water. And it makes sense. Like, look, they are adapted to eating sticks, okay? There's really not any understory here. There is some forbs under here, and this is a dappled light environment when it's not overcast. But we should also note that this is the only place in Colorado and in our landscape where there'd be like prolific inputs of leaves, of carboniferous material with which to build soil. And so I kind of think it's cool right now to just really appreciate what a deciduous tree does for the soil. And in the grassland, obviously, there's deciduous production, or excuse me, carboniferous material decomposing. But as we go upstream more into the montane, the deep dark forest, it's almost subalpine like, but we're still down here in town. It's very northeast facing. We're gonna see that there's nothing in the understory, because the major inputs, even in the riparian, are needles, and they don't break down as quickly. So this is a very rich and biodiverse landscape. I think I mentioned like 7 or 8 tree species. And the other ones that might be here are like gooseberry, currant. If we see those, we'll take a look. So we've been talking a bit about like the effect of light, how much light there is on the landscape in ecology. And here we are in this riparian forest. And we were talking about how this little patch right here kind of has like a good mix of age classes for the various species. There's also a lot of species, some of which are native and some which are non-native. But here we see what I would think of as a more historical like situation for a forest where the mammals are able to do their thing, eating the vegetation, predating on each other, etc. So we have all age classes, but it's pretty dark. So let's take a look. We put our quadrat down, and if you recall, the way we measure this would be to go along and see what is rooted in each square. And the vegetation is senescing right now, so it's kind of hard to tell. But if we look around, it doesn't really look like there's things rooted in here at all. But we have a ton of material buildup. This is the makings of some very rich soil. And that's from all the leaves that fall from the sky. And oh, look, this little tree isn't even actually in our plot. So in a random placement of the plot, the density of tree saplings is 0. The thing we see here is what would naturally happen. So remember when we were at Concrete Coyote, like we were in kind of a steep zone right here. You can see that there's incising and there's cut banks, right? Under these trees are eroded, and we can see bare ground, right? We can see rock. It's not fully sedimented. But notice how the rocks are creating a structure where the water drops, and this actually introduces oxygen, which is really important for aquatic species. And when we read about that in the textbook, I think I remember back in the day like thinking that it was more complex than that, right? But dissolved oxygen is literally just oxygen mixed into the water. And how does it get mixed into the water? Like through natural features like this. So one thing Sam said was like, oh, well, these giant pieces of riprap are kind of doing their job. And this is what he means from an ecosystem perspective. But I will also point out that this is not a clear bottom, okay? What you see in the column is decomposed granite, and this is a ton of sedimentation, okay? Most fish do not like to lay their eggs in this stuff. So when we think about what the pollutants might be in a water column, rocks are a form of pollution, and so roads up above contribute to erosion. And I don't know how far my comrades want to walk, but they are building this huge water retention complex upstream of us, but I feel like they're just ripping into the landscape, and like it's going to cause more sedimentation. And actually, the road, Pikes Peak Highway, caused serious environmental damage, and that was another time when we were sued by the federal government for poor management. So we've got the sedimentation there, which is partially an issue of our geology. The Pikes Peak granite is a highly erosive mineral substrate. But we have these other rocks doing their job, these larger pieces, to create dissolved oxygen, a very important component to the riparian system. So we drove up to High Drive, and we're just at the trailhead still, but this is like a walk of some sort. And so we're in this primary order stream. We were talking about stream order, which I assume you've had in a different class, but basically the primary order is the first stream coming off the headwaters. So we're just a couple miles out of town, but this is a primary order stream because Bear Creek starts up in these mountains. So look, in just the first several miles of the stream, we have our first diversion, right? The dam or diversion. So anyone for Edward Abbey, monkey wrench graying, this is basically like the death of the Western River, is regulation of it. So here we are in what we consider the most pristine and award-winning waters of our Pikes Peak region, and it has this on it right away. But I will mention that it is providing the ecosystem service of adding dissolved oxygen because there's a drop right there. And there you can see that the debris in this creek is, as we were discussing, primarily needles because we have moved up, and although we're only about at the elevation of the montane life zone, this is just northeast facing. We are tucked up in here, and this does not see the light of day. And once the snow falls here in January, typically it holds for at least 40 days or so. And so here we have an assemblage in the overstory, which is much higher. We have Doug fir primarily right here, but also some spruce, and we see some Ponderosa pine still here. And then in the understory we have those native riparians, including the lance-leaf cottonwood and the alder, mountain maple, all shown right here. Okay, so we just haphazardly threw this. It wasn't a truly random selection. But, you know, if we were going to look at the veg plot here in the primarily evergreen forest, we see that there's still like development of carboniferous material, but it's primarily needles and cones and wood debris. So trees that are adapted to fire tend to shed off a lot of their lower limbs, so there is technically a lot of wood debris here. We are seeing a few forb species under here, not a whole lot of grass, but a little bit. So we can see that basically the inputs from the vegetation are completely different from what they were just about 1 mile downstream. Okay, here's the Doug fir cone, and Pseudotsuga menziesii. And notice that there's these little papery bracts, and cones are kind of like grasses. Inside of each part of the cone is an independent fertilization event. And so these are wind pollinated. Here's the flat friendly fir. The needles have only 2 sides, and so they don't roll in your fingers. The Doug fir have these white lines on the back, and the needles are coming right out of the stem. They're not in packets like a pine. And then if we go up, we might see it somewhere better, but we just go. That cone that I showed you is the female cone. But the male cones are just these soft little tufts, and the male cones are usually inferior. They're much smaller. But the cones are typically at the top, the male cones, and then if you can imagine the pollen, the gametes, they float down to the female cones. So there's wind-assisted pollination. Here we are looking down at the drainage. We're on the road, but we're looking back down at the creek. And we've got the aspen there, and we were talking about how there's 4 species of populus in Colorado. The Populus deltoides in the plains, the Lanceolata lanceleaf, which is a native, and then acuminata, which is the narrow-leaf cottonwood, which I believe is the hybrid. I can't remember if the lanceleaf or the narrow-leaf is the hybrid between the other and the deltoides. Then you gain elevation, and you get to the Populus tremuloides, the quaking aspens, and then once you gain life zones, you know, it becomes wetter, it becomes more mesic. So the populus are not restricted to the riparian area, but here they are in the riparian area. And also notice we were talking about how plants have root systems that are connected, and this is a means of survival. So take a look, like all those aspens, they are all one organism. They are all connected by the same root system. And the reason why this is a good way to go is that if you have damage from pathogens like insects or from animals eating, you can just shoot up a new stem and your whole organism is not lost. And you can see all those cankers on that aspen that's kind of bendy on the right. That's from pathogens. Aspens have more bug infestations than any other tree in Colorado. So I've been told, but have not researched. Alright, one quick correction. So the lanceleaf cottonwood is the hybrid of the plains and narrowleaf cottonwoods. Alright, now we're just standing here on the road base. So here we are on the road base. And here is the Pikes Peak granite. Okay? It's just super erosive. So every time it rains, you can see this is sediment from me kicking it is going all the way down to the creek. It's super steep. You can still see that there's the heterogeneity created by the boulders, but the entire bottom is covered in this sediment stuff, and that is an environmental problem. We're also talking about this pipe. We're not sure exactly what's going on with it, but we think that there was or is a reservoir above. Alright, so one of the other abundant evergreens here is Ponderosa pines. So you can see the cones are a lot woodier, they're bigger. And also the needles are in pokey packets. Okay, so see this packet comes off of the stem, and you can identify tree pines by how many needles are in the packet. Also notice how long the needles are. So Ponderosa have the longest needles of all evergreens in Colorado. Anywhere from 3 to 4 feet. Or, excuse me, 3 to 4 inches. And then this one knuckle on your thumb is an inch. So you could just hold your finger up like this and estimate how long the needle is. Then as we look up, see, this is a stately Ponderosa. You can see that the needles look like tufts. This is the center tree. But then this needle in the foreground is the fir. Doesn't look like tufts. And look, there's evidence of fire damage, but the tree has persisted. And the Ponderosa have lots of adaptations to withstand frequent low intensity fire. So the Ponderosa have this really thick bark. Also, we were talking about how a lot of evergreens just like self-limb, and this is a measure to reduce the ladder fuels, right? It's just part of adaptation. So if you don't have a lot of ladder fuels, then as an individual tree, more likely to survive, more likely to give offspring, and that is evolution. So we just entered this like construction zone, and I'm not sure what they're doing, and we're behind the tape, but we're gonna go see. So remember when we were back at the headwaters of where the locks were, at the trailhead, excuse me, not the headwaters, and there's that like black soot all over the rocks, and I said I hadn't seen that before. I assume that it's this very fine silty soil. See how fine that is? It just gets stuck all over my fingers, and if you were an aquatic organism, that would be getting all up in your breathing mechanisms, in your open circulatory system. So I don't know what they're doing, but they're just ripping into this, knocking down trees, causing sedimentation. Are they? Look at the water. Let's see if we can focus on the water. You can kind of see how the water is sort of cloudy. And they're doing some kind of recontouring over there. Not sure exactly what it is.
Hi, I am Amy Sherman. I work for a company called Flywater, and we're over here in Bear Creek working on some river restoration. And the purpose behind the restoration is that this stretch of river is the only natural reproducing, genetically pure population of the state fish, the greenback historic trout. And with some flooding and the location of the road, there's a lot of inputs of sediment. I don't know if you look at the road, it's like a lot of this smaller gravelly type material. So in bigger flood events, there's been a lot of that coming into the creek. There's a gully right here that's a big input, so we're realigning the river to get away from that gully so that when there are big events, that material can still come down, but it won't get in the river, because that material is filling in the deeper pools that the fish need for overwintering habitat. We're doing another realignment upstream as well on another input area, and then we'll be moving downstream a little bit and just spot treating some areas where the pools have filled in and digging out those pools. That's kind of the gist of the project. But
Yeah, well, thank you.
Yeah.
Alright, so now we're a bit upstream. Here's a good place to look at how woody debris, as we increase in elevation in riparian areas, we see that the overstory is evergreens. They like to self-limb. There's more woody debris creating the drops and steps and creating that heterogeneity in the stream corridor. But let's take a look at what's going on here. So this is going through some culvert under the road. But then, this is all new. So these are like a form of check dams right here. And the point of it is to create that heterogeneity. So if there was a large storm event coming down the road, the water would hopefully pool in these check dams and slow down. And notice that the goal here is that these are vegetated. And this drives me really bonkers, but this is a like spray on revegetation technique, but it really gives rise to non-native development. So like you can see there's I think this is just a piece of, this just might be trash actually that the contractors left behind. But this is just plastic, right? But then this stuff is just like ground up straw, and there's some seed in there, and I think they use like a hydro application. But it really bothers me because they are not using native seeds. So all of these plants that are popping up are a non-native phlox, and it's really pretty, but it is not native. Can I say that one more time? The plants that are native to here are working in harmony with the insects, the animals, the birds. When you introduce non-native species, you kind of mess up the trophic levels. It's brand new food. It's a McDonald's for for wild species. Also, like, what other chemicals are in this crazy stuff? It's bright green. So we're putting that right next to the river, and it just all makes me so sad. We can do a similar revegetation effort like we saw in the Garden of the Gods, or on like the dam face in Red Rock Open Space, which broke a couple years ago. And so you could do a kind of, it's called, you know, easy matting type stuff. Like you could apply some kind of erosion matting, but you can plant into it native species. You don't have to use these non-native species. And in their local applications, in my own research, it's been highly successful because this phlox stuff needs a lot of water, and it grows like 2 or 3 feet high, and then it's a fire danger. So here we've got all this riprap. Here's this, what I consider lazy revegetation. And then the creek's coming right out. But my point is that if the floodwaters come cruising over here, we're putting all this weird stuff just right back into this creek, which we just heard is there's an endemic fish species here, blue ribbon trout waters, most pristine waters close to town, and still in their primary order. So no inputs from other streams soiling the water quality. Okay, so we've been kind of like monitoring the clarity of the water as we walk, and remember how at the very bottom at the trailhead we saw that really fine silty material. Then we touched it, and now we're downstream of the restoration project, but look at the water, it's just so milky with sediment. And then over here, you know, you can see the Pikes Peak granite is the understory here. So yeah, I wonder how long it will take after they do that work to reduce the sediment, for the sediment that they created to settle back down. So in order for them to produce a long-term gain, they're causing a short-term disaster, from my particular opinion.